But I made this very simple dummy load out of these resistors here, thinking, hey, resistors are resistors, but
It'll be easy, but you can see here on the Smith chart, it's 50 ohms. This is inside of the QRP dummy loads, but I thought, let's key down. Wow. In today's video, we're going to have a look at a homebrew dummy load that I've built, the trials and tribulations of the previous dummy load I was using and how it was a dummy load. And I'm also going to show you a brand new SWR and power meter that I've ordered, and you get a demonstration of that, and we do a bit of a power test on the output of the Baofeng UV10R to see how many watts comes out of that, and we finally solve the mystery of how much power my 2-transistor transmitter is putting out, and loads more. So hope you enjoy the video. It's a long one. Fast forward if it's getting boring in places, but there's a lot happening in it. And comment below, let me know what you think of the videos, and I'd love to see you as a subscriber, so like and subscribe. Well, they do say if you wish for something hard enough, it'll appear. And I've ordered this stuff to calibrate my Oz QRP kit, which is an 80 meter kit. So I'm very excited, and it's also gear that I'm going to need anyway. Let's get the unboxing underway. So the first thing that we've got is, it's a small package. I'm just wondering whether it's, well, hey, I'm not going to do a spoiler. Let's open it and have a look. Okay. I don't know what that is. That looks like, God only knows. Our microphone. And this is going to be the microphone. It's a speaker microphone. It's not the Baofeng one. It's probably made by the same company in China. 2 pins, one for mic, one for speaker. And that's going to be used on my Oz QRP transceiver. And also what's great about it is, if I ever manage to get this checked out for spurious emissions, my Baofeng UV10, I will be able to use this microphone as a speaker microphone on this as well. And I have not given up on the Baofeng. It's an opportunity to learn about bandpass filters, and if I can get a bandpass filter in here that'll take out spurious emissions, if there is any spurious emissions, we don't know yet. That'll be happening in a future video. Oh, well, a chance to actually check that the speaker's working. It's actually sounding not too bad.
Cancel.
And that's the speaker. And we won't have too much music because we know what YouTube's going to do with that. So I'm happy with that thus far. Obviously, we've got to see what the quality is like on transmit, but that will be my 80 meter double sideband microphone for the Oz QRP DCT transceiver. Let's have a look at what's in here. And this has come through QSL Communications and sent express post. So Mark in Caloundra, thus far I'm saying thank you, because we always like a quick parcel. And it is an SWR power meter, the AV1000, which is 1.8 to 160 megahertz, and then 430 to 1300 megahertz. So 2 meter band, 70 centimeter band, and it's got HF covered as well. I did order a El Cheapo one that was just HF, and it looked more like a CB one than a proper amateur one, and it was through Kogan. It was because it was listed as being in stock, and then of course you order it, and then a week later you get a phone call from someone saying, well, actually it's not in stock and we're waiting for the container to come from China. So don't appreciate that happening. And up until now, Kogan's been really good for me. We've dealt with them on numerous occasions, but that was a little bit of a disappointment. Be still my beating heart. It was packed in bubble wrap very nicely, and this packaging is a sight to behold. Bubble wrap to the extreme, which is great for precision. I can't even say precision. For a precision instrument, Jesus, it looks like it's gonna do what we need it to do. So very happy with that. It's a 13.8 volt input, which is what my supply does. So yes, once again, happy about that also. And you can see on the back here what look like PL259s for the different frequencies, the different ranges that are listed. It comes with instructions as well. I'll get it out of the packet and we can have a look at it. So that's the unit there, and I like the look of it. I'm very excited about that. It's certainly well made. Metal case, all metal, which for an RF instrument is always a nice thing. And it's got different ranges on it. And we've got 400 watt, 200 watt ranges as well. I am damn pleased with that. I'm on the front here for the range. We've got 5, 20 and 200 watt, and my stations are 5 watts. So it's overkill. But if I ever decide that I'm going to go to the dark side and use high power, I'm tooled up for that as well. So that is the power meter. So I am now in a position where I can get my transceiver producing RF. I think I need to obviously make those patch cables and make a dummy load that isn't made with wire wound resistors, because the one I have is not flat across the frequency spectrum because it's got inductance in it. So I'm going to have to get some 5 watt resistors and parallel them up and just get to the point where I've got a reliable dummy load that I can utilize. We've pretty much got everything we need for the moment. My wife just keeps shaking her head every time she sees the credit card bill, and I just keep going, just one more thing. So it's it's fun, and life's too short. So I'm going to make some radio play for a little while until uni starts, and then I'll be back into the study. Okay, so this is the AV1000, and I purchased this product from QSL Communications, Mark Roberts, in Caloundra, Queensland. And I've got to say, it was sent out express post via a parcel box, and it arrived very quickly. And unlike the one that I ordered through Kogan, which they said they had in stock and they didn't, it was a little bit more expensive than the Kogan one, but the Kogan one was basically just an HF model. And I think, once again, it was lucky that it didn't come, because in many respects I've found out that by trying to save money, you end up costing yourself money, because there's one thing that's certain with this hobby: once the bug bites, you're going to want to do more and more with your equipment. And I would have just had an HF very low wattage meter. Now this meter here will do up to 200 watts. I'm not a linear person. I've never been a linear person. I'm really quite enamored with the idea of QRP. So that's more than likely what I'm going to do. But if I ever do get a 100 watt rig, I'm able to take SWR and power measurements from that rig. So we've got a 5 watt range, a 20 watt range, and a 200 watt range. Now it runs on a 13.8 volt power supply, but if you don't have power, it still operates. Basically what happens is these lights on the front don't light up, and the actual backlight for the meter doesn't come on, but it will still operate without a power supply. So if you were in the field and you didn't want to wire it up, you would still be able to use it. So they're the power measurements for the range. It actually says they're 400 watt, so I don't know what that is about. And at the top scale it says 400, so I think that's probably another model, because the only range I've got on here is up to 200. No, I stand corrected on that. If you look at the back here, there's actually a switch here that you can push down for 200 or 400 watts. So it will go to 400 watts. That wasn't made very, very clear. There is a provision for increasing the wattage, and that's a 200, 400 watt selector switch on the back. We'll go back to the back in a little moment. Front panel, you've got a PEP and an average switch here. Cal to get it full scale when you're doing your SWR measurements. So you normally put it in Cal to get a full scale measurement, and then flick it to SWR and you'll get your SWR measurement. And you've got forward and reflected power here as well. So pretty standard really as SWR meter controls go. Now if we look at the back, we have inputs for their SO239s. We have 400, 200 watt switch here. This side here is anything from 430 to 1300 megahertz. And this side over here is 1.8 megahertz to 160 megahertz. And this switch here is switch number 16, and it's the sensor 2 and sensor 1 switch. So I am assuming that when you start flicking that switch, and we will have a look when we switch it on in a moment, you start flicking that switch, you'll find that these lights light up depending on which one you've got selected for particular range that you're looking for. So it goes 1.8 to 160, then 430 to 450, 800 to 930, and 1240 to 1030. So that's what that switch on the back, I'm assuming, will do. But we shall see when we switch it on. Anyway, let's get it powered up and have a look at it. Another thing that I have realized, and I should have realized it from the start, was that you can get RG58 coax that has stranded center conductor, and you can also get it with a solid copper conductor. Well, that's what I found. So I'm pretty sure the spec for RG58 is a solid center. But at any rate, the coax I got from one of the Jaycar stores was stranded. And so I was crimping onto a stranded wire, which is not very effective. So the last few that I've done on the end of the antenna cable, I've actually thrown a bit of solder on them so they'll stay where they are. Not crimped, I've just soldered them on. This new cable that I just got has a solid conductor in the center, so it'll crimp a lot better. So I've made another cable, and I was going to just make cables with one end PL259 to go on these SO239 connectors on the back of the SWR meter, but I actually opted in the end for screw down converters. I'm not going to be working up in super high frequencies, and so I'm not too concerned about insertion losses and whatnot. So this should be fine. So we're going to now plug this bad boy in and have a look at how much power is actually coming out into a 50 ohm load for this transmitter. Because I'm really curious. It's drawing about 2.4 watts when I did the calculation. And I want to see how much actually is getting to the dummy load. So let's have a look. So this is our setup. We've got it running into the supply, and like I said, you don't have to have the supply, but this is backlit, and it's at the moment the light that's coming on is for, if you look here, the 430 band. So if you flick at the back here, that's going up in bands, and so that's now on the HF 1.8 to 160 megahertz, and we need to select low wattage, which is 5 watts, and I'll set the camera up so we're not going to get seasick, and we'll have a look at what the output power is for this little 2 transistor rig. Okay, the moment of truth is at hand. Let's look at the bottom scale here. It's going from 0 to 5. Let's zoom in, see if we can zoom in. Key down. Wow. Okay, so we're about 400 milliwatts. So I'm really surprised that this thing gets out as well as it gets out. I was expecting a little bit more power than that. And let's have a look and see, because I'm going into a dummy load that's basically 2 100 ohm resistors that are 1 watters. So that's more than enough for this rig. I am going to make another dummy load so we can test the Baofeng as well and see whether the UV10R really does put out, well, you know, the rumor is always that it's called a 10R because it's got 10 watts out, but from the internet I would say that we're looking at, you know, anything from 4 to 6 watts. I did actually run this dummy load with the resistors on the Nano VNA just to see how it responded to frequency, and it was fine. But what I did find out, and people will just be like shaking their heads and going, this guy's a doofus, but you know, I'm a bit slow on the uptake. This dummy load that I made, thinking, wow, that's going to be great. It'll do 10 watts and it'll all be good. Well, they're wire wound resistors, so of course they're inductive and they respond really badly to even HF. So as a dissipation for a non-RF load, not a problem at all. But anything that's generating a frequency that's too high, the inductor is going to act as a choke, and it's not going to present as a 50 ohm load. So really dumb. But I've bought a whole bunch of these resistors. I think I bought them in 400 ohm value, so 100 ohm value, and I'm going to series them and then parallel them and get myself to 50 ohms with a dummy load that'll take about up to 6 watts continuous. So it'll probably be good for more than that, just for quick bursts to check a transmitter. Transmitters that I've got presently are going to be 5 watters, so it'll be more than enough to look after those transmitters. So far, the AV1000 looks like it's behaving itself. It's not going to be much use for me to swar this antenna tuner with this meter with this particular transmitter, because it's such a tiny amount of output. But once I've got my 5 watt OzQRP transmitter, it'll be fine for that. And yeah, I'm looking forward to utilizing this SWR meter, the AV1000. Let me know if you've got an AV1000 in your shack and how you found it to be. I'm not going to say that this is a strong endorsement for it yet, because I haven't had a chance to use it. I just wanted to show you a new toy that I have, and I pulled it out so that we could have a look at what the output wattage was on the transmitter. So, you know, 300 or 400 milliwatts up the spout, and I managed to hear it last night in South Australia and in Gladstone, Queensland. So, you know, over 1,000 kilometers away. The magic of radio. So just a quick word on how this dummy load's being made. You know, it's basic Ohm's law. I've got 1 watt resistors, 4 of them. Now obviously if you get a higher wattage resistor that's not wire wound, that's going to be a lot better. But this is what I could find. It was quick to get. I was in JCar, so this is what I've got. So I make up 8 of these 400 ohm resistors using the 100s. And then I parallel them up. 1, 2, 3, 4, 5, 6, 7. There's 8 of them. So you know that when you get 2 resistors in parallel, you're halving their value. So these are each 400. These blocks here, each one of them is 400. There's 8 of them. So this becomes 200. This becomes 200. This becomes 200. And this becomes 200. And when you put the two 200s together, this becomes 100, and 200 ohm resistors in parallel becomes 100. So you've got 2 100s in parallel, and then when you put 2 100s together, you get a 50 ohm load. Now, that's a quick way of doing it in your head. Obviously, you could use the formula for parallel resistors. I'm not going to do an Ohm's law lesson here, but that's the circuit. I'll show you the work that's going into making it. So basically what I've done is I've got a whole bunch of these 100 ohm resistors and put them in series, and that's the 8 of them. And I was going to try and just do them like this, but they're probably going to short out on each other. So I'm probably going to grab a little bit of Veroboard or something just to hold them in position. And I want to try and minimize the lead lengths as well. Admittedly, this is probably going to be used at HF, so it's not going to be an issue, but still, you know, make it as well as you can. So it was pretty obvious that with, you know, a 10% error on each of these resistors, that we weren't going to end up with 50 ohms. So I'm a dummy. What I ended up doing was I grabbed one of these jumper leads, and I just started taking resistors out of the circuit and basically got myself to the point where this is now 49 and a bit ohms. So close enough to 50 for me. It's in an old money box, and it's got a BNC on the end of it. So, you know, 5 or 6 watt dummy load that'll do the trick. So let's jump over to the Baofeng and just see how much power we get out in full power. So as dummy loads go, this is probably not going to work very well. Leads are too long. Shut up, multimeter. Leads are too long. Its SWR is going to be terrible. But power we've got. This is the Baofeng plugged into a 50 ohm dummy load. Admittedly, not a perfect match, so you're not going to get perfect power transfer. I think the SWR's just marginally okay, like it's on about a 3. But when you consider the fact that when you plug the actual antenna that's supplied with this in, it's not much better than that on SWR anyway. It's not a perfect match by any long shot of the imagination. You can see on the 20 watt scale that we're getting at about 3 or 4 watts. So with a better match, you'd probably get higher than that, but it's definitely not 10. And just so you know that we're not lying about the characteristic impedance of this dummy load that we've just made, let's just chuck a multimeter on it and have a look at what we come up with. So it's a little over 50 ohms, 52 ohms. I can live with that. We've got a meter now. We've got a dummy load fit for QRP purposes. You wouldn't want to put more than 6 watts into that. It's in its little case. These stick down standoffs are absolute rubbish, but it doesn't really matter because the wires are stiff and the wires are what really holds it in position more than anything else anyway. It ain't going anywhere. Cheap solution to the problem. I don't need to use the dummy too often, but it's nice to have something to load up a transmitter to peak up the power for HF. That's me for this look at this AV1000. This is not a definitive appraisal of its performance. I'll have to have it in the shack a lot longer than that to actually give it a thumbs up endorsement, but thus far it appears to be working well. It's got lots of functionality. It looks like it's well put together, solidly built. I am thus far very happy. $200 for something that covers that range of frequencies is I think a pretty good deal. And the thing I've noticed online is they're very hard to get now. Every time you go to get one of these things, it's not in stock, and you have to get it from China, and you have to wait, weeks and weeks for it to arrive. I needed it now. This was a good price, and like I said, the gentleman in question delivered it on time. This is once again the inside of the QRP dummy load, and obviously using 10% tolerance resistors and using so many of them, I was really making it difficult for myself, because we're always going to end up with an impedance or resistance that was going to be higher than what we required. I've just put a little tap in here. I just did that experimentally, tapping around until I got something that was approximating 50 ohms. But I thought better run it through the Nano VNA, and I've only done this for a 3.5 megahertz band because that's what I'll be using this dummy load for the time being. I might do an HF 3 to 30 as well, which is what I'll also be using. But you can see here on the Smith chart, it's 50 ohms, pure resistance, dead smack bang in the middle of the Smith chart. So it's doing what it needs to do, and yeah, I can use it, not worry. Obviously, being as those resistors are 1 watters, this dummy load's probably only good for up to about 5 watts. This is the same test using 3.5 to 29 megahertz. So there's a little bit of reactance there, but the actual plot's still staying roughly in the center. So there's a little bit of a inductive hump there, but they're still very usable on HF. I wouldn't be too confident chucking 2 meters into this, but it's for my HF use, and I strongly suspect for VHF it'll still be alright. Yeah, as strongly suspected, for 2 meters it's not in the center of the chart. The wonderful sound of rain on a metal roof. Welcome to sunny Sydney. Well, I'm hoping it's a sun shower. Well, if you're still here, thank you for watching the entire video, or at least getting to the end of the video if you've fast forwarded through the boring bits. Presently, I'm having a really great time in the shack. Last night I was trying to do a CQ call using a software-defined radio online one. I could hear it. It was about 300 or 400 k's away, and I was using that to listen. And I've now got that 2 transistor transmitter frequency agile, so I can actually cover part of the bottom end of the 80 meter band. That means that it matches my direct conversion receiver. So I'm going to chuck it all onto a board, and I've ordered some power transistors because I blew up the final in my kit that I'm building, and so I asked for 2. So hopefully, if I don't manage to blow the one up that I put in there, I will keep the spare one and I will use it to up the wattage on the transmitter to hopefully I'll get a watt or 2 out of it. And That will make it a much more usable transmitter. And I'm going to sit it all on one big board so I can keep experimenting with it, keep it open. I will put the transmitter in a metal case so that the oscillator doesn't interfere with the receiver as much. And hopefully I'll end up with a QRP transmitter receiver combination that it can actually be used. And I'm going to keep it old school. I was going to put the DDS VFO on it, but now I've decided I'm going to keep that DDS VFO and I'm going to use it to maybe build a 7 megahertz transceiver, and that'll be before I attack the QCX Mini, because I think the QCX Mini I'm going to wait till the next holidays when I've had a lot more practice at soldering and I'm more mentally inclined to be there and do a good job on it. 73s from the Lunatic Painter VK2 AOE and the Art of Engineering. See you in the next video.